Question: for some positive and distinct real numbers of x, y and z, if 1 by root of y plus root z is the arithmetic mean of 1 by root x plus root z and 1 by root x plus root y, then the relationship which will always hold true is question. So they have said that this is the arithmetic mean of the other two, so I can write this as 2 into root of y plus root z will be equal to 1 by root x plus root z plus 1 by root x plus root y. So I'm going to rationalize the equation. So I end up with y minus z root x minus root z divided by x minus z. So 1 by, that is root x minus root y divided by x minus y. So after this I am going to check from the options. I am going to substitute each and every option, check whether that particular option satisfies the given equation. So I'm going to start with B and D because they are simple to apply. So starting with D, they have said that x, y, z are an arithmetic progression, which means y minus x and z minus y should have a common difference, D. So this should be equal to D and this should be equal to D, and z minus x should be equal to 2D. So upon substituting these values in the given equation doesn't hold true. So left hand side is not equal to right hand side. So option D is ruled out from the given options. So I'm going to check for B now. So they have said that y comma x comma z are an arithmetic progression, which means x minus y equal to D and z minus x equal to D and z minus y equal to 2D. So upon substituting the equation, so let's check. So 2 into root of y minus root of z divided by y minus z is equal to minus 2D. This is equal to root x minus root z divided by x minus z. X minus z is nothing but minus d, and root of x minus root of y divided by x minus y is nothing but d. So I am going to add the right hand side and check whether I am able to end up the value at the right hand side. So root x minus root z minus d plus root x minus root y d can be written as d minus root x plus root z plus root x minus root y. So root x gets cancelled. So I am ending up with root z minus root y by d. So which is equal to the right hand side. So right hand side value is nothing but root y minus root z by minus d, which can be written as root z minus root y by d. So right hand side value is equal to left hand side. So option B is the correct answer for this given question.